Let's connect to our master. Any questions from previous class? Have anyone tried out, watched the recording, or any questions? Before, meanwhile, I'll connect to the master node. Okay, so let's begin. Like we were talking about yesterday, the config map secrets, right? And we were talking about using the secret to pull the images from ECR, Docker Hub, and so on. Correct? Today, let us proceed and talk about something called volumes. Like what are these volumes? Where do we use these volumes and all? Let's talk about it. First, let me put the proper image so that we can use the volume. See, first I'll show you the concept of volumes. Then we'll implement these volumes, config maps, everything to the PHP-db app. Okay. Until then, I would like to use the same image, the older image, which is V1. Okay. Deploy one. Okay. Apply -f, deploy one. Get all the pods. And yeah, these are the pods. Let me delete other objects. First, let me clean up the unused things. kubectl delete daemon set, and the daemon set name is Prometheus daemon set. I'm just getting rid of this. And also let me delete other deployments. Delete deploy to. Okay. So get PO. Okay, so 2 pods I'm having, which is fine. So now let's talk about volume. Volume is like, we know what is a volume, right? To share the data, to back up the data, we use a volume. Maybe it might be a database pod where you have to take backup kind of. So here in Kubernetes, you can implement this with a concept called persistent volumes. PVs, right? That's called persistent volume. This is a physical storage, okay? And this should be attached to the pod, correct? So you don't straight away attach PV to the pod. Rather, you will have another layer called PVC, which is called persistent volume claim. Okay. So what happens? PV is the physical storage, actual storage on the server. This will be attached to the claim. Claim will in turn attach to the pod. Right? Whenever you create a pod, you create the claim. Claim will be attached to the pod. And there might be multiple volumes on the server. PVC will attach to the particular PV. It will search and attach to the PV by matching the access modes and by matching the capacity and by matching the storage class. There were certain criteria. Means you create a PVC. Okay, PVC should be attached to the PV. Means PVC will attach to the PV, which will be matching, which will be having the same access mode, same capacity. Means PVC capacity should be smaller than the storage class. Sorry, capacity should be, PVC capacity should be less than the PV capacity. And the storage class should match. Means what could be the access modes first? Access modes might be like a read write, okay, read only kind of. So if you create PVC with read write, your PV should also have the read write mode. Capacity. Your PV capacity is, let's say, 1 GB. Right? It will attach to any PV which is more or equal to 1 GB. But if your PV is less, it will not attach. It will be just hanging. Right? Similarly, storage class. Storage class is like in our case, it's a manual. You can also have dynamic storage class. Dynamically, it can create the storage. As of now, we'll be having storage on the same server, right? But best practice is it should be on a remote, isn't it? If something goes to happens to the cluster, you should have a storage properly configured, right? So all of this should be taken care of. First, let's create a PV, then we'll create PVC. Okay, then we'll create a pod. Pod will attach to PVC. PVC will in turn attach to PV. You may be having a question, why do we need so many layers? Directly pod can attach to PV, right? Here, this provides a layer of abstraction so that this PV will be taken care by admins. This might be taken care by the developers. Here, developers means who work for configuring the application, like Kubernetes developer, not the developer who write the code. We mean Kubernetes developer. This is Kubernetes admin. Again, what is Kubernetes developer and Kubernetes admin? Not that every company will have separate team like Kubernetes developers and admins. Some companies may have separate teams. Some companies, they may have only one team. If it is one team, we need to manage everything. But if there are different teams, Kubernetes admin will take care of configuring the servers, volumes, the underlying configurations, backup, and so on. Developers means who configure the pods. What is a pod requirement by setting the pod configurations like the labels, how much capacity this pod needs. So they'll create the claims. Means they'll not be bothered about where is this volume created, whether this has been backed up, whether it is been on the same server or remote server. All of those things, Kubernetes developer will not be bothered about, right? So to have this difference, like so that they can, developers can deploy irrespective all of this, and admins can take care of only the underlying things, configurations. So to make the thing simple for each one, we have this kind of abstraction, right? So what we'll do here is first we'll create a volume. Okay, then we'll create PVCs, then we'll attach them to the pods, right? Let's get to the hands-on. Before that, any questions from anyone? Can we go ahead? Like any other Kubernetes object, you can say get PV, nothing found. Let's create a PV. Yeah. Again, a manifest file. Okay, pv.yml. You can get the manifest file from the official documentation of Kubernetes. This is the one. See, persistent volume. Kind is persistent volume now. Okay, name is test PV. It's on local machine. Storage class is manual. Like we were creating them manually. Storage is 1 GB. Read write many. Host path means, okay, this volume should be on which location. I'm giving MNT data. It should be present on which node? Should it be present on worker node or master node? MNT data. It should be there wherever your pod is running. Basically, if you're maintaining on the same server, it should be on the worker node. Okay, so that's where it should be. Also, yeah, first let's create it. Apply -f PV. Apply -f PV. Okay, get PV, right? So it tells you that it's available. Storage class manual, all the information you have configured. But it's not bound to anything. Status will be bound if it's attached. We don't have PVC, right? You can check them with get PVC. There's nothing. So let's create it. Okay, get the PVC. Yeah, this was also, see, persistent volume claim. Test PVC. Local. See, storage class should match, I'm telling you, right? So PVC, if it is manual, it can attach to the PVs which are manual only. Okay, and also it should match this read-write mode and this capacity. So all of them matches, so it should attach to it. So let us save it and let us create it. Apply. Okay, now if you see volume get PV, see it's bound. Earlier it was available, there is no claim, but now it was bound to it, right? Then PVC. It was bound, you can see that. Get PV, get PVC, right? But it is, see here, this is also bound, but now, okay, fine. On the worker node, we have configured MNT data path. That should be attached to the pod, right? First, let's connect to the worker node and create and see that we have that path. Okay. Okay, this is worker node. Now we have given MNT path, MNT data. This volume should be on the machine wherever your pod is running. We don't have it. We can create it. Let's go to MNT. Now let me create here a directory called anywhere you can create. Okay. Go to data. Okay, here let's say I just want to have index.hu. Just created some sample file over this in this part. Okay, MNT data. Now come back to the master node. Let us describe PV. I have only one PV, so yes, this is the host path. Bare host directory volume. Like on the host machine, this path should be mapped inside the pod. How do you map it? Through the volume. Hmm. Deploy one dot, yeah. Right here, like we configured all of these environment variables, we could configure the volume as well. You have to attach PVC to the pod. So under the specifications, like we configured the containers, the same level of indentation, we configure the volumes. Okay, some name to the volume. See, it's not properly named. Okay, volumes, name of the volume, PV storage. So I'm just giving the name here. PV storage, but this will be coming from persistent volume claim. Persistent volume claim. Right? Because that's our claim name. And okay, fine, this will attach to the claim. But what is the path in the container that should be mapped, isn't it? That's where we'll add an attribute called volume mounts. Let's come here. Let's add volume mounts. Volume mounts. Mount path. Mount path. You see, actually, it's an Nginx image, so I just want to share this index file. So HTML file basically Nginx HTML. Okay, means I'm just sharing the file here. Name of the volume we were attaching is this one, right? PV storage. So what's happening here? I have a volume. This is on worker one. In the path, MNT data. And the volume name is test PV. This is attached to PVC. Okay, this name is test PVC. Test PVC. That should be attached to pod. Okay, and the pod is attached to this test PVC. Okay, fine. This test is, but where is the path inside the pod? It's USR share Nginx HTML. Means actually this path in the pod is mapped to this pod on the node, on the worker node. Understood this mapping, everyone? Yeah. How are we mapping? PV will be attached to PVC. PVC will be attached to the pod through these attributes. Volumes, volume mounts. That's a volume mount. Got it clear, everyone? Can we apply? Thank you for confirming. So yes, the change is applied, but before that, let me check the service. Already service is deployed. 30,001. Yeah, this is the one which is there. But now, let me apply the change. kubectl apply minus f deploy one dot yml. What is that? Mapping values. So indentation errors. You could have copied it from the official documentation. 21, line number 21. Persistent volume claim and the claim name. Persistent volume claim. Claim name is test PVC. PV storage is 111 designation. Claim name. I was showing this as an error, but I believe this is the problem. This should be same level to ENV. Let's check. Still, line number 21, mapping values are not allowed in this context. Where did we map? Persistent volume claim. This is name PV storage. Let me check in official documentation. Yes. Volume bound options. Yeah, name, persistent volume. This is what we were using. Name and persistent volume should be of. Yeah, these are at the same level of indentation, right? So that's what it's not nested. It's at the same level of indentation. Yes. Okay. So okay, now let's see. Let's see the pods. They were running and let's describe them. Describe first. Let's again pod. Describe pod name. Here you can see persistent volume claim test PVC. It's attached and it is running. Let's get inside the pod. Exec minus IT. Bin bash. Okay, you get the shell here. So let's go to that path which we have given. This is the path inside the pod, right? USR, share, Nginx, HTML. So if you go there and if you see, this is the file we have created in this MNT data, do you remember? So that was added up here, meaning now after this one, I should see, yes. Understood? That's how you can deploy through volumes. Got it, everyone? Any questions? That is about volumes and volume claims. We have seen a simple scenario of place in the slide. We will see this to have a backup of our database, like SQL database is there. We'll see having a backup of that in our PHP-db application. All right. That's going to be our next project where we'll implement all of them and deploy PHP-db. Right? So get PV, PVC, and pods, right? So if you want to clean up, first you have to delete the pods, then the PVC, then PV. In the reverse route, you can't delete the PV. It says it is already bound. You can't delete the PV directly, right? Can you cat the PV PVC YAML file? Sure, Dinesh. PV and PVC. Wait, I'll show you with a clear PV PVC. In the volume, we have configured this path. In the pod configurations, we have mounted this claim to this USR share and share. Now shall we deploy our PHP-db app? So now let's talk about our PHP-db project, right? We have two microservices, PHP and database. Now can you tell me what are all the objects we need to create to deploy PHP? First, let's talk about PHP. What are all the Kubernetes objects we want? See, we need to create a deployment object, isn't it? PHP pod should be running. We already have a Docker image. Service should be there, right? Do we need any volumes, any config maps, secrets for PHP? I don't think we need them. But here another deployment object, another service object. We may use config to pass the config map to pass the DB name, correct? Similarly, you may use secret to pass DB password, correct? And then, yes, we need volumes, volume claims, and both of them need Docker Hub secret, correct? To pull the private images. Am I correct? So, how many objects? For PHP, it's two objects. For DB, it's like 1, 2, 3, 4, 5, 6. Total 8. And then this is the one 9. Total 9 objects we need. So we'll create all of them and we'll create this PHP-db, right? Like the application should be running. Shall we get started? Let me first clean up. Get deploy. Only one deployment. Let me clean up. kubectl delete deploy one. Okay, that's deleted. What else we have? kubectl get pv get PVC. First, let me pods are gone, so let's delete PVC. Delete PVC. Test PVC. kubectl. Okay, it says it is gone. Now, if you see PV, you still have it, right? It says it is retained. Status is released. Let's delete this. Delete PV test PV. Okay, so done. So I just cleaned up all the volumes, everything, just to keep it clean. Let me also delete the services. kubectl get service. Delete service. Delete service one. Service two. Okay, gone. Right? So now let's create the PHP thing. I'm going to create a directory, a separate directory for it. For PHP-db files. Okay, first PHP. I'll deploy PHP. Okay, and I'm going to create a YAML file called web.yml. Here I need deployment object, service object. We can place all of them in the same file also. That is also fine. Okay, you can keep everything in the same file separated by this by three hyphens this way. Deployment object we have already learned. Same thing I am using. Even this one we have learned service object which is not bought. Go through it and let me know if you have any questions. It was nothing new. Same thing we did, but the secret name is it's a Docker Hub. Yesterday we created. Please go through it for a minute and let me know if this is clear or any questions you have. See, this is the private image for PHP. You can put all the objects in the same file also separated by three hyphens. But it's too many objects, that's not preferable, but only two objects for PHP, so I'm doing it. Go through every line, please. Are we good? Let's apply this. See, it says deployment service created. Let's see. It's 132,001. Okay, get deploy. Get PO. 32,001. So let's add this port. Let me remove unnecessary ones. Ingress, this is for ingress, this is for 32,001. Okay. Okay, so yes, I have the front end ready, but back end is not yet ready, right? So now let's go for the back end. So for back end database name, you may use config map, or else database name is configured in the image itself. Do you remember? Docker file of the SQL. So you may not need it, but still if you want, you can create it. I'll create a secret for it. Okay. So let's go to Php-db folder. Here I have two of them. Oh, I created them outside. Oh, okay. Let me just move it. Web.yml into PHP. Okay, just placing them separately. Okay. Now let's create a secret as MySQL secret dot yml. Right, the secret for database password. If you want, you can set it in Docker file also, like we did earlier, or else as we have secrets, we can pass them this way. I'm just writing it. If you want, you can put it in the encrypted, base64 encrypted format also fine. Let me create the secret. Apply -f MySQL secret created. Right? Now volumes, right? So PV underscore MySQL.ym. So you have to create as many number of volumes as you will have the pods. As of now, I'm going to start only one pod, so one will do. Or else if you want two, you can create two volumes. I'm creating two volumes. See here, this time I'm going to create under reset user as MySQL one for one pod, and this is for the second one. Right, MySQL 2. I'm creating two of them. For now, let it be. Let us put this. as one volume. Okay, we'll talk about the second one later. Let's say, yes, this is the volume. Same volume of file, persistent volume file we created before. PVC for SQL. And this PVC will be mounted inside the pod, from inside the pod, right? So this is okay, right? MySQL PVC local manual 1 gibbs. Okay. Let me create the volume first. Apply minus FPV and then PVC. Now kubectl get PV. Yes, it's bound already to this claim, MySQL PVC claim, this one. Okay. And the secret, let me apply secret also. Apply minus F. Get secret. So this is SQL password. And Docker Hub, this is for pulling the images from private Docker Hub. Right? So done. Let's create deployment and service for this as well. Let me name it as db.yml. We just connected, like we just created all these objects separately and learned them, right? Now we were connecting the dots, like we were creating all of them, putting them so that they all work together for one application. So see here, deployment, deploy to, label is MySQL, one replica, labels is MySQL. Key is, what is the key? Docker Hub. So let me change the key. Key name I have given as Docker Hub. Right? And see here, this is the MySQL store attached to MySQL views. That just some time back, like we created for a default one, same thing, right? And the private image. Root password coming from secret. And volume mounts attached to this volume attached to this. But actually, the path in the pod is valid MySQL. If you remember, through compose, we deployed it. Correct? So the same thing I have done. And I don't need the service to be exposed outside. So it will simply cluster IP type of service. Any questions in this part, please go through it and let me know. Is this file good? So let me write over again. For PHP, we created deployment object, service object. For database, MySQL database, we again created deployment object, service, a secret to store password, PV, PVC. Right? And all of them we have created one more secret to pull images. The secret name is Docker Hub. So how many objects in total? 1, 2, 3, 4, 5, 6, 7, 8 objects in total. If you want, we can also create a config map to set another environment. See, this is environment variable, right? MySQL root password. Similarly, we have one more my pass daily name. If you want, you can set them as another environment variable through config map. So total 8 objects we were using for this. Any questions? Is this much clear? Can I apply it? Thank you, Shalab, for confirming. We learned them separately. Now we were putting all of them together for this. Let's deploy it. Minus F db dot by m. It says it got created. Kubectl get pods. Right, db1 is getting created. Meanwhile, the service. See, SQL is cluster IP because I don't want to expose it to end users. Only this is the front end. If you want, you can also put them on ingress. So all of them are running. Now, first let's see the volume, right? We have configured the volume on the worker node because your pod is running here, right? And it's home EC2 user MySQL one. Let me show you. Describe a PV. See, home EC2 user MySQL one. If this directory is not there, it will create it. So let's go to the worker node to see that volume. Home EC2 user. See, MySQL one is created. And yes, you have everything whichever is inside the pod database backup. Right? That same thing we did in Compose, right? Now I'll try to submit. Yes. Insert failed because data is not correct. It's too long. We have given varchar 10 only, means it will take only 10 characters. So it was working fine. Absolutely fine. So even though this pod is gone or something happened in the record, you have a backup. New pod will come up with the data. If you want, you can check the data inside this kubectl get pods, kubectl exec minus -it. Bin bash. What did we do? Oh, sorry. Is this okay? Master node only. It was taking long to attach. Okay. See, 1050 port should be open to allow connecting to them. So 10250, that's a default port. Let's open that. I just removed 1052, right? So let me add it. 10250. Okay, now let's start. Yes, okay. So now we want to go to var lib MySQL. Yes, this is the one which is backed up onto the worker node, correct? This is the one. Also, let's connect to the database. MySQL minus u root minus p. It prompt for password. Now use my database. This also can be configured through volume, right? Database name. So select star from EMB. See, two values which I have entered. If this pod is gone, what if this pod is gone? No problem. Another pod will come up. Let's delete this pod. Sorry. kubectl get pods. I'm deleting database pod. Delete pod. See, if you delete pod, pod will come up automatically because it's a deployment object. It will make sure always it has one replica. Means whatever replica number you configure, it will keep on coming up with that. Let it go away. And get PO. See, another pod started. You see immediately with a different ID 12 seconds back. Now let's get into this pod. Exec. It is X52, this one. 52WL. MySQL minus U root. It's a new pod, still it should have data. Use my database. select start from EMP. It has this data, right? Old data, as well as if you again put some new data, all of that will be present. See, too long again. Okay. Right? Perfect, right? Like how we deploy through Compose. But in Compose, it's only on single server. Of course, with Swarm, you can do it on multiple hosts, but still you don't have this high availability, rolling updates, rollbacks. Now, if you want a new version of PHP, that's possible here with a zero downtime, right? You can increase the replicas. All of these are advantages with when you deploy it through Kubernetes. Got it clear, everyone? Understood? Am I clear? Thank you, Shalab, for confirming. So this is about PHP-db deployment using all the objects we have learned till now, right? We can enhance it with further, like we deployed DB with the deployment object. We will be deploying it through stateful sets. So what are stateful sets? Why do we need them? We shall get into all of that in the next class tomorrow. Right? Practice till this much. This will take a lot of time for you to figure out and create each of them. But all the objects we have created. And the code is available on the repository as well. The link is available in your Google Drive to the repository where you have all the files. You can use them and deploy it. Right? Any questions? Let me know. And from we shall take up from here in the next session. Anything else? Any more questions from anyone? All can be created. Yes, Dinesh, you can put all of them in a single file, but it's not good for managing or maintenance. So we create separate manifestos. But if it is two objects, you may add them. Fine. But yeah, if you want, you can put all of them in a single file. You can do it. Any more queries? All right, then we'll continue from here in the next class. Thank you all. Have a good day. Bye, everyone.